Yes, so Srikant students, let's discuss what is lens, class 10, optics, reflection and refraction. We have already seen a mirror is having one reflecting surface, right? And based upon what is a reflecting surface, we divided mirrors. In case of lens, it's like we have two lenses. One is convex lens, other is concave lens. Well, students, we know this is our convex mirror, right? If you remember, the convex mirror is that mirror in which the reflecting surface is protruding outwards, is bulging outwards. Now, students, what you do, don't shade this area. Take one convex mirror. This is one convex mirror, right? This area is not shaded, it's not painted, right? We will take another convex mirror, right, students? Put them like this, and then what we do? We get rid of this area, we remove this area by bracing or whatever it is, and then these two areas, when they join, become two reflecting surfaces, and that is known as convex lens. This is known as convex lens. All right, students? Similarly, students, we get what is concave lens. In case of concave lens, well, this is a concave lens, right? This is concave lens, right? Normally in a concave lens, this is a, in case of concave mirror, this is the reflecting surface and this surface is painted, but we don't paint it. Now we take one more concave mirror, and then we get rid of this area, and then we join two mirrors to get what we call as what, students? Two concave mirrors have been joined to get a concave lens. Now, students, understanding this will help us to understand why lens has two foci and two centers of curvatures. Why? You see, it's made up of two mirrors. Convex lens has been made up of two convex mirrors. So every mirror is having its sphere. This mirror also has a sphere. So obviously, if we take a common principal axis, the center of the convex lens is known as optical center. We write it by O. In case of, if you remember, convex mirror, we used to call it pole, and pole was actually on the mirror. Whether it was concave mirror, pole was on the mirror, but the optical center is not on the lens, it's inside the lens. Beautiful. Now this convex mirror has this focus and this center of curvature, and this one, let's say this one is having its own focus and center of curvature. And that's the reason, students, we say a convex lens has two foci and two centers of curvature, right? Similarly, in the case of concave lens, all right, so this is important, right? F1, F2, then we have C1, C2. So the concept of lens is explained. Why? One more interesting thing, students. If I say that concave mirror is converging, means the rays which are falling on this try to converge. This is convergence. On the opposite, a concave lens is diverging. Why? The rays come, the ray come, and it gets refracted. Remember, students, in case of our mirrors, there was the physical phenomenon known as reflection, light falling on a surface and getting reflected by some law known as law of reflection. This was our normal, which was touching C. But what is refraction? Refraction is, students, we say these are two mediums, right, students? One is air and other is, let us say, glass. Now, students, air is known as optically lighter medium. And this one, the glass, is known as optically denser medium. Students, interestingly, this lighter and denser has nothing to do with the density, which is equal to mass by volume. It has nothing to do with the density. There is very high percentage of teachers and students which think that if medium is optically lighter, it means its density is less. No, students, it's not like that. Simply, students, see that if you have a glass slab, this is a glass slab, right? We call it prism also. Fine, it can be prism, call it slab, glass slab, some thickness, it has some thickness. This is a glass slab. Now, students, a ray of light is coming. A ray of light comes. Now, in the glass slab, it gets diverted. The direction of this changes. Well, you'll take some time to understand why it happens. Not so easy to understand. From one medium to other medium, if a light passes, it changes its direction. It's true. It changes its direction and the velocity also changes. Students, in air or in vacuum, mostly we say the light travels with the speed of 3 into 10 raised to power. Any student, how much? In air or in vacuum, the light travels with the speed of 3 into 10 raised to power. Come on. 3 into 10 raised to power. How much meter per second? 3 into 10 raised to power 8 meter per second. Approximately 1,80,000 miles light can travel in 1 second. In 1 second, 1,80,000 miles. And interestingly, this light doesn't need any medium to travel. From sun to earth, lot of portion of light, lot of portion of the path in which light travels, there's this perfect vacuum. It travels. It doesn't need any medium, just like sound. So this speed of light is here 3 into 10 raised to power 8 meter per second. When it enters the glass, it changes its direction. And let's say it changes in, let's say it comes in this direction and finally it again goes in this direction. Now, how do we define optically lighter medium? Optically lighter medium is the medium, in this case it is air, where the speed of light is more. And optically denser medium, in this case it is glass, is simply the medium where the speed of light is, any student? Optically denser, more optically denser medium, less is the speed of light in that medium. We say very light optically, very light optically medium, light, optically lighter medium, optically lighter, or we say optically rarer medium, are both same things. Optically rarer medium, optically denser medium. It has nothing to do with the density. It's possible that a medium may be optically rarer or denser, but the speed of light could be, what we think, not like that. So, we're very clear. Optically denser medium is a medium in which speed of light is, any student, less. And optically rarer medium in which speed of light is comparatively more. Okay. So, when the light is refracted, here it's refracted because it is entering air. Light is entering optically rarer medium to optically denser medium. This lens is made up of glass. In the glass, light travels at lesser speed. So we say this is optically denser medium. So students, its direction will change. This is incident ray. This is the refracted ray, not reflected. This is the refracted ray. Here RR means refracted ray. There RR used to means reflected ray. Very interesting physics. So students, here you have seen, because light is going like this and then it's getting scattered to a bigger area, we say this is diverging. So we say this, your mirror, your concave mirror is convergent, your concave lens is divergent. Exactly the same thing. You talk about your, convex mirror. Convex mirror, this is the incident radiation. This is the reflected radiation. This is the reflected radiation. There is scattering. Light is coming in between less area and getting reflected in a bigger area. This is divergence. So your convex mirror is diverging mirror. Whereas students, very interesting, your convex lenses, light is coming from here, ray is coming from here. Ray is always, we assume that coming from left. We always imagine the object is always at the left, is always at the left. And the distance between object and the mirror or the lens is known as, anyone? Distance between object or mirror, is it U or V? Anybody remembers the last lecture? Distance between the object and the mirror or object and the lens is known as U. And what is V? Any student? Please help. Sargun, what is V?
Image distance.
Correct. Distance of image from the lens or from the mirror. So you see that this convex lens, light is coming, it's getting refracted and it's trying to come towards focus, means it's occupying less area. This is known as converging. So this is, remember, if a concave lens is something, a concave mirror would be opposite. All right. So these are simple things I told you about light, about everything. All right. And now we see, students, that how we can understand the different images of convex mirror. So this is our convex mirror. This is our convex mirror, students. Beautiful. This is a convex mirror. Now we're going to draw the principal axis. This is our principal axis, and everybody understands this lens will have two focus and two center of curvature. Have you understood? Say yes or no.
Yes, sir.
Correct. Beautiful. This is the, what is this? Inside the lens, optical center, right? Optical center. This is represented by O. So here would be F1, and this would be what, students? This would be
C.
what? You can
C.
call it C1. You can also call it 2F1. You know why? Because we know that this distance is focal length, and this distance, if you call it C and O, will be double of focal length. So we represent this point sometimes at 2F1. Have you understood? Just indicating that this distance is half of this distance. Got it, students? So F1 to F1. Similarly, this will be, come on, students, F,
F2.
F2 and F2
2
and
F2.
F2 and 2.
2 F2.
Beautiful. F2 and 2 F2. All right. So first case, just like now this convex lens, you know, how many reflecting surfaces it has? It has both the surfaces are, both the surfaces are reflecting surface. But now we talk about refraction, right? Okay, in case of lens, we talk about refraction. So none of the surface is painted. That's what I wanted to say. None of the surfaces, it has two surfaces. None of the surface is painted. All right, so, but we always think the object is on the left of the lens. Hence, U is always negative or positive? Yes, students, please help me. U is always negative. All right. So first case is object is, all the cases of convex lens match with concave mirror. We had 6 cases in concave mirror. Possibly we'll have 6 cases in convex lens also. So students, let's discuss all the cases one by one here. Now, the rays are coming from infinity, very simple, parallel to principal axis. Rays are coming from principal axis after getting refraction. I told you, whenever light travels from one medium to other medium, its direction will change. So it's going inside the mirror. It's going inside this medium. This is different medium. And this air is different. Air is optically rarer medium. Glass is optically denser medium. Sargun, can you tell me what is optically denser medium? Mehtab? Optically denser medium, student, is a medium in which speed of light will be, anyone? Less. Okay. So from here, the rays are getting refracted and they will pass through focus. Okay, first case is done. All right, second case, students. Now the object is, object, you can say, students, object is, let's say, beyond 2F1. All right, this is my second case. Object is beyond 2F1. I want to see where will be the image. All right, there in concave mirror, what we used to do, if you remember, from the tip of the object, I used to draw a parallel line. From the tip of the object, I used to draw a ray passing through C. Here, I will not pass the ray through C, rather I will pass the ray through O. That's it. You can draw all cases yourself. So students, first ray parallel to principal axis, and obviously any ray parallel to principal axis, it will pass through focus after getting refracted from the mirror. After getting refracted through the mirror. Okay. Now, the second ray I told you from tip of the object passing through optical center. Where is the image? Tell me. Where is the image? Where these two lines are intersecting, that is the image. So where is the image? Tell me. Image is where? Come on, students.
Between F2 and 2F.
In between, come on, students, F2 and 2F2. And it's lesser in size and it is real. Why it's real? Because these rays are actually there. This ray and this ray is actually there. They're both getting refracted and they are both intersecting. They are not virtual. They are not extended. So it's real image and it's inverted. And it is lesser in size. You can see this is more, this is lesser. Third case. Third case, now I bring what? I bring this object and to F1. Very interesting. This is similar to concave mirror. Can anyone guess where will be the image? Can anyone guess? Do anyone remembers in concave mirror when the object was at C, where was the image?
At 3 only.
Let's see. Here, let's see where is the image. Okay. Hope we are successful. First ray parallel to principal axis of the object. This may be a pencil, this may be a candle, this may be some camera, anything, you know. Okay, so first ray parallel to principal axis. Obviously, it will pass through what? Student? Pass through? It will pass through?
Line.
All right. It will pass through focus. All right, this will pass through focus. Now, students, the second ray, anybody can tell me what should I do? What should I do for the second ray? Second ray pass through the, come on, students, pass through optical center. Can you tell where is the image? See, first object was at 2F1. The image is at
2F2.
Image is at 2F2 and the image is equal in size. Can you see that? It is equal in size, right? Beautiful. Let's go further. All right. So once again, what was the first case? Object was at infinity. Where was the image? At focus. In case of convex lens. Second case, come on, students. Object was beyond 2F1. Where was the image? Second case. Yes, students. Between
F2 and 2F2.
F2. Third case, object is at 2F1. The image is at 2F2. Four case. Now, what will be the where will be the object? Object is between 2F1 and F1. Between this. Right? Where will be image? So we will see, we will ask geometry. We will not worry. This is the object. Then this is the ray passing through this. And this ray passing through the center. Passing through center. Okay, can you see, students? Automatically geometry is telling everything. Can you tell where is the image? Students, where is the image? Where is the image? Image is here. Yes, where is the image? This is the image. This is the image where these two lines, one line coming from, this is incident ray and this is refracted ray passing through focus, and passing through optical center where they are intersecting. This is the image. So image is this is between 2f1 and f1. So we would say ahead of 2f2. Okay, fifth case. Now students, object is, yes, where will be the object? Come on students. Object will be, I'll bring the object to f1. Okay, if the object is at f1, object is at f1, object is at f1. This is the ray passing through focus, and the second ray passing through the optical center. Optical centers, beautiful. Can you tell students where will be the image?
Infinity.
Beautiful. See, that geometry is telling you, you need not remember anything. The fine way you draw it, you'll enjoy. Beautiful. So here the object was at f1, at focus, just like concave mirror, and the image is at infinity. All right. It will be inverted. It will be inverted. It will be real, and it will be highly magnified. You know, because as you go down and down, this size is increasing. So, okay, fine. So the last case, students, what is the last case? Last case is, tell me anyone, what will be the last case? Yes, students, what will be the last case? Last case is, students, the object is between f1, sorry, between this is the object. Object is between F1 and O. So what will I do, students? Object is between F1 and O. And now what will you do? Remember, we were a little, kind of stuck when we were doing concave mirror also. So same way, here there's a little problem. So can anyone guess where will be the object? Where will be the image? And how we will draw it? So students, I tell you one thing. In case of lens, now what will you do? Now, you have seen all the cases. Now students, your object is between F1 and O. Don't worry. You draw this line. You draw a line, parallel to principal axis. This line will pass through. Come on. After getting refracted, it will pass through. Come on, students. Focus. And the second line, don't worry. Here you need not do anything. You just pass through O. Now, student, please tell me, are these two rays going to meet or not? These two rays. You can see, are these rays going to meet or not? Tell me fast.
No, sir.
They are not going to meet. They are not going to meet. They are not going to meet. So there will be no image. No, there is an image. Please extend them to the backward. So I am using red color to extend them backwards. Okay, I'm using red color. No, I'm not able to use red color. No, it's showing same color, but it should be dotted line. Actually, it should be dotted line. I'm not able to draw. I'm sorry. I'm not able to draw, but you should draw. When you take back, you should draw dotted line. You see, students, these two rays, when they are produced backwards, they are meeting here, and they are meeting exactly. You see, all the answers are coming correct. This is the image. I'm sorry. This is the image So object is this. This is the height of object, students. Height of object may be h and height of image is h dash. So can you tell me in this case what will be magnification? Magnification is always size of height of image divided by height of object. It will be far greater than 1. So only in this case, in case of convex lens, the image will be, see, they are extended backwards. These are not real rays. The real rays are going in this direction and they are nowhere meeting. So these rays are extended. And students, I told you, whenever the rays are extended, the image is, anyone? The image is, come on.
Virtual.
Image is virtual. Image is Monroe's. Are you understanding? Mehtab, Hartik, Ashdeep. Okay, hope you're understanding. Okay, so students, these are the 6 cases. So 5th case was object was at F1, image is at infinity. 6th case, between F1 and O, the image is virtual, and it is behind the lens. This is, we say behind, and this is ahead of lens. Ahead matlab lens to agge. This is behind the lens. Okay, students, all the cases are discussed. Okay, I would request you to see this video again so that you understand, and share with your friends, subscribe the channel. All the best.